All right, today we're diving into one of the most exciting frontiers in AI. We're going to talk about how computers are moving way beyond just crunching text and are starting to develop something you could almost call senses. Yeah, we're talking about AI that can see, hear, and understand the world in a way that feels a lot more human. You see, for the longest time, AI was kind of a one-trick pony. You had one model that was a genius with language and a completely different one that could pick out objects in a photo. But that whole era, it's coming to an end. What we're seeing now is a massive shift away from these isolated, single-purpose AIs towards something that's way more integrated, way more powerful, and honestly, a lot more like us. So, how in the world is this leap even happening? Well, the core idea, when you boil it down, is pretty simple. AI is getting senses. It's learning to see, to hear, and to process information from all these different sources at the same time, just like we do. And I want to be clear, this isn't just a minor upgrade. It's a total game changer in how AI perceives and interacts with everything. To really get our heads around this, we need to talk about the lingo. We're basically moving from something called unimodal AI to multimodal AI. So let's break down what that actually means and why this shift from a siloed approach to an integrated one is such a huge deal. Okay, the magic words on this slide are within a single model. This is so important. We're not just talking about duct typing a language model to an image model and calling it a day. No. The real magic, the breakthrough, is having one single unified system that can process, understand, and actually find the connections between text, pictures, and sound all at once. And this chart right here, it shows the jump perfectly. Think about it like this. A regular old chatbot can read your words, but it has no idea if you're being sarcastic, right? It can't hear the tone in your voice. It can't see the funny picture you're referring to. It's just got the text. A multimodal system, on the other hand, can process your speech, analyze the emotion in it, and see the image you sent, all at the same time. This creates a massively richer context, which, of course, leads to way more accurate and nuanced conversations. Okay, so we've got the what, but what about the how? How does an AI actually pull this off? Let's pop the hood for a second and take a quick look at the core mechanics that let a single AI blend all these different kinds of information together. It really boils down to three key steps. First up is data fusion. You can think of this like a chef mixing ingredients. It's all about bringing different data types, like text and images, into one shared space, one recipe. Next, you've got cross-modal learning. This is where the AI starts to figure out the relationship between the ingredients. It learns that the word cat is connected to a picture of a cat. And finally, there's co-attention. This basically acts like a spotlight. For any task, it helps the AI zero in on the most important parts of the picture and the most relevant words, while ignoring all the background noise. And look, this isn't just some abstract theory. It's already having a massive impact out in the real world. I mean, in healthcare, an AI can analyze an MRI scan while also reading the doctor's notes, potentially spotting things a human might miss. For self-driving cars, it's absolutely crucial, fusing data from cameras, radar, and sound to navigate our chaotic streets safely. You see it everywhere. This is creating a much, much more complete picture of reality. So this idea of integrating sight, sound, and language, it's a huge leap forward, but it kind of begs a question, doesn't it? What is the actual technology that unlocked all this? What was the big breakthrough that made it all possible? Well, the answer lies in something that researchers call the transformer revolution. It turns out there's one specific model architecture that has become the absolute backbone for pretty much all of modern AI, including these incredibly powerful multimodal systems. And that answer is the transformer. This one single, elegant piece of architecture is the engine driving almost everything we think of as modern AI, from the language skills of ChatGPT to the most advanced models that can see and hear. It is truly the hero of this entire story. And if you want to see just how fast it took over, just look at this timeline. The original paper that introduced the transformer was only published in 2017. In just a few short years, it has completely dominated the entire field. All the big names you hear about, OpenAI's GPT, Meta's Llama, Google's Gemini, guess what? They're all built on this exact same foundation. It's been an unbelievable takeover. But, as with any technology that becomes this dominant, you have to start asking the next big question. Is this it? Is the transformer the final word in AI architecture? Or are we already starting to see its limits, which is pushing researchers to hunt for whatever comes next? And yeah, there are limits. Transformers are incredibly powerful, but they are also absolute beasts when it comes to computation, which makes them super expensive to run. They can still hallucinate, which means they just confidently make stuff up. And maybe most importantly, they have what's called a low inductive bias. Now, that's just a fancy way of saying they don't have a lot of built-in common sense, so they need to see just unimaginable amounts of data to learn things that are obvious to us. These are the big problems driving the search for the next breakthrough. Which brings us to the final and most important question that researchers are asking themselves right now. Are transformers all we can do? Because while they have literally given AI senses and have completely changed our world, the quest for the next more efficient, more powerful architecture is already well underway. And figuring out what that will be, well, that's the next chapter in the story of AI. Thanks for watching.